By default, Intel Aero is acting as a Wi-Fi access point. It is very convenient for the initial calibration on control user interface access. Access point name is Aero with the MAC address of your drone, and password is as described. So you can connect your development station to this network, then launch SSH on IP 192.168.8.1. Login is root, and there is no password. You can set a password after connecting. So you can access Intel Aero over the access point included, set up by default, but the drone is not connected to internet with this method. So you can't install packages or do things like that. There is also an optional local USB connectivity. So if you plug a direct micro USB cable between your PC and Intel Aero without an OTG cable, it will create a USB Ethernet adapter on your laptop and allocate an IP address for your PC. So Aero will act as a DHCP server in a way. So you can access Intel Aero over this USB cable with IP 192.168.7.2. Each OS on installation has different ways to handle networking, so this method may interfere with your setup. For example, on Ubuntu, Network Manager may potentially disable your internet access when you are using this network because it will think it is a main network, and later it may drop the connection with the drone. So it is an advanced method. That's why we recommend to use the following wireless access method. It's a lot simpler. But if you need it, it's available. So we've seen that by default, Intel Aero is acting as an access point, but for development, you'll want to connect Intel Aero to your Wi-Fi network to access internet, install packages, and access Aero remotely from your development computer. So this action is done using the keyboard, mouse, and screen connect to Intel Aero. And after this step, you'll access Aero remotely and won't need them anymore. So the full procedure is detailed on the GitHub. No problem. So with the previous method, it was Intel Aero giving the IP address to your PC or to Qcon control. So it was easy to know. It's our decision. But if you are connecting Aero to an access point at home or at work, you won't really know what is the IP address of your drone unless you ask your router what was the IP allocated to your drone, and it's different for each network. So here I typed IP addr to get the IP address of Aero when I'm connected with a screen and keyboard, and in my case you can see the output, it's .1.105. We recommend you set a fixed DHCP reservation. Ask your system administrator on how to do that with your local network. It's very convenient. So now that Intel Aero is connected to the same network as your development station, you can connect remotely to Aero with SSH, a copy file with SCP. On Windows, you can use a SSH client called PuTTY, on FileZilla for SCP. On Mac and Linux, it's included in the shell. We recommend you set a password because it's an open system. By default, there is no password, so it's better to have one. So there are different ways to develop software on Aero. You are root, it's a remote Linux machine. So there is nothing specific about Aero, but just to give you an overview, you can potentially edit sources on your station and transfer them to Intel Aero for execution. In this example, I'm using the idle editor on Mac for Python, and I transfer the files with SCP, and I execute them on Aero. But you can also remotely edit with VI the files on Intel Aero and execute them and compile them locally on Aero. Aero has a full Linux system with build, toolchain, make, Python, VI, everything you need to develop software locally. To summarize, we connected Intel Aero to our Wi-Fi network. We understood the details of command CTL to connect the Wi-Fi network, and we have SSH access from our workstation, so we can edit, compile, execute everything. So now we are ready to code.